We're writing the year 2011. I was hired recently by a logistics firm in order to help them plan out a budget for the upcoming year 2012. Like any other company involved in the transportation business, this firm is heavily impacted by changes in gas prices. My job was simply to collect data on gas prices and to make forecasts. The firm was planning on using those forecasts in order to make the right budget projection, which ultimately influences almost any business decision the company has to make. I started out by collecting data between 1986 and 2011, and I mapped it out here for you. And you can, for example, observe a rapid increase in prices starting at 2002, 2003, or a sudden drop in prices in 2009, which is most likely an unpredictable occurrence. I also include in this graph a regression line, and looking at this, it becomes obvious that we wouldn't have been able to use a regression model in order to make a one-year prediction because the line here does not resemble the actual values at all. Another thing that I knew right away was that I wouldn't have to worry about any seasonality affecting my data because I was only concerned with average prices for an entire year at a time. So I started out with some smoothing methods, and I started with a moving average of 3, 6, and 9 years. And here in this graph, you can see that the more years I take into consideration, the smoother the model gets and less responsive to sudden changes in prices. After that, I did weighted moving averages of 3 and 6 years. And here you can see that both those models are more responsive to changes in prices, and that is because more weight or more importance is put on recent occurrences. And then I did some exponential smoothing and assigned alpha the values of 0.1, 0.3, 0.5, and 0.8. And here we can observe that the model's responsiveness increases as alpha increases. And we can see here at the bottom in orange, there's a line of the model where alpha is 0.1 and it's the least responsive to changes in prices. And then all the way at the top in yellow, we can see the line of the model with where alpha is 0.8 and it's the most responsive to changes in prices. So after doing some of these smoothing methods, I picked out 5 possible candidates and I ran accuracy comparisons on them. And I picked out the exponential smoothing model where alpha is 0.8, then one where alpha is 0.5. I did the 6-year weighted average, the 3-year weighted average, and the 3-year moving average. And I also included the regression just as a reference point. And I did error measurements. And one thing that sticks out right away is value for tracking signal values. And it becomes obvious that, or it sticks out that those values for tracking signal are very high, and this could possibly make my predictions suspect. On the other hand, when we're looking at the other error measurements, they're all very low and suggest that I could possibly use any of these models as my final model. The problem with that is that when you choose your final model, you also have to take the predictions and compare them to the actual values. And after doing that, I decided to choose the exponential smoothing model where alpha is 0.8 as my final model. And this model is the most responsive model out of any of the models, and that's because alpha is very high at 0.8. I chose this model because it was not only it didn't have only the best results in error measurements, but it also came closest to the actual values, which is just described by alpha being that high. Based on my calculations of this model, I predicted that the average gas price in 2012 will be $3.42. Using my forecast value, the firm now has a better idea about how much money they can expect to pay for gas in 2012. This is essential because it helps the business plan out an annual budget and it helps the company make educated business decisions. Obviously, predicting gas prices accurately is very hard. This is because unforeseeable events can change the entire industry in a heartbeat, as we have seen, for example, in 08-09. Undoubtedly, there's always risk-taking involved when including something like predicted gas prices in budget proposals. However, at the end of the day, all businesses, and that includes logistics firms, have to have budget projections. And therefore, using a model like mine that responds quickly to changes in gas prices is the best way to go. Thank you.